I'm Anqifu from Osaka University, Graduate School of Engineering. And today I'm honored to present our latest research finding, generating 4D plant models for virtual reality environment using the instant neural graphic primitives and stable diffusion model. In VR environment design, realistic plant models are crucial for immersive experience. However, traditional 3D modeling methods have limitations in capturing the seasonal dynamic changes of plants, making it difficult to fully reproduce the realistic form and details of plants under different seasons. This highlights the necessity of developing efficient methods to create dynamic plant models. The innovation of this paper lies in introducing the time dimension into VR plant modeling. As shown in this flowchart, our method covered the entire process from the input of plant images and temporal information to 3D modeling, temporal variation simulation, image optimization, and temporal variation simulation, and tree structure refinement. Instant NGP is responsible for 3D modeling, while Stable Diffusion model handles temporal variation simulation, and the LoRa model is used for image optimization. In terms of related work, we draw on the latest advance in neural reading, particularly instant NGP. This method utilizes neural networks to learn an implicit representation of 3D scenes, achieving high-quality novel view synthesis and geometric construction. And Stable Diffusion model was chosen for the seasonal change selection. We also considered another method, such as generated adversarial networks, but after comparison, the Stable Diffusion model outperformed GAN in terms of structural logic and textual details. Next, let's delve into the method we propose. As illustrated, it includes several main steps. Firstly is the video capture, and then frame extraction, and then image processing and analysis, 3D scenes creation, seasonal change simulation, and the integration of changes into the 3D scenes. Taking a sampler maple tree as an example, we first use the instant NGP to create its 3D model, and then employed Stable Diffusion for seasonal transformation, generating a winter maple tree. It was mentioning that we also leverage LoRa and CAADRIA to further enhance the quality of these results. LoRa as an efficient fine-tuning technique play a key role in our method. By injecting trainable rank decomposition matrix in the attention layer of the pre-trained model, it achieves significant performance improvements while reducing the number of training parameters. We first prepared a cross-seasonal plant images dataset and used the blip neural network to automatically annotate each image. Then we trained the LoRa model using the CAADRIA framework and select the best model for the seasonal transformation task. Now let's take a sample maple tree as an example to see how the Stable Diffusion model works. First, we input the original photo and the corresponding text prompt, triggering our pre-trained LoRa model. The text prompt plays a key role here, guiding the model to generate the desired seasonal features. However, the text prompt alone are not sufficient to ensure the realism and consistency of the generated image. This is where ControlNet comes into play. ControlNet is a conditional generative model that leverages prior knowledge to guide the Stable Diffusion model in generating more realistic and consistent results. In our method, ControlNet is mainly applied in three aspects. Edge detection. It helps maintain the structure and shape of tree, ensuring a reasonable branch structure across different seasons. And deep analysis. It utilizes the deep information to understand the 3D layout of the scenes, correctly handling the front-back relationship of the tree and its interaction with the background. And finally, the semantic segmentation. It distinguishes the different parts of the tree, enabling the model to independently control the seasonal changes of each part. In terms of the experimental results, we conducted the comprehensive test on the virtual maple tree. As shown in this image, our method successfully simulated realistic changes from spring, autumn, late autumn, and winter. For quantitative evaluations, we use metrics such as PSNR, SSM, and LPIPS to measure the quality of the generated images. The results show that our method achieves good results in this table. Despite the encouraged results achieved by our method, there are still some limitations. For example, in this video, in a real park scenes shown in this video, the quality of the images generated by the Stable Diffusion model decreased due to the complex of the scenes, resulting in some noise and holes. In the future, we plan to explore improvements in simulating multiple planes at the same time, handling collision and complex structure, improving the realism of the seasonal transition, and introduce VR interactions. And in summary, this research has made significant progress in 4D scenes reconstruction and VR plant modeling. Our method improves reconstruction accuracy and enhancing the ability to capture temporal changes in 3D scenes with potential application in various fields. Finally, please enjoy this. Finally, please enjoy this view of the generated later autumn maple tree in VR environment, showcasing our research results. And thank you for your attention.
Okay, very interesting papers. Any questions around? Oh wow, okay, that's fast.
So I wondered Well, the method you use of implementing sort of the processed image back into the INGP was using a COMAP evaluated data set and sort of do the whole nerve network one more time. Right?
I'm so sorry, I can't listen very clearly.
So after you have processed all the tree images with stable diffusion and control net, you then pass them into instant NGP with COMAP for their position, right?
Yes.
I think in sort of like from a computer science point of view, there is a better method of doing this, which is called SDS, scored distillation sampling. There are 3 papers related to that. One of those is called instruct nerve to nerve, which is exactly doing what you sort of have proposed today. It kind of handles or sort of seasonal transition, style transition from a nerve directly to nerve without the need of going through COMAP for the second time. So scored distillation sampling is essentially, so a diffusion model sort of predicts the noise from the input image. So instead of denoising, generate a new image, scored distillation sampling directly put that noise through back propagation. So it goes all the way back to the nerve model, update that instead of sort of doing all the COMAP for the second time. So I think it would probably be a great help to look into those papers. The first one with SDS is called Dream Fusion. There is an improved version of that by Tsinghua University, which is called Variational Distillation Sampling. The paper is called Prolific Dreamer, and there is one specifically doing a nerve-to-nerve sort of like transition kind of thing, which is called instruct nerve-to-nerve.
Thank you very much.
So there is more of a comment. Okay, are you from computer science? Okay, interesting. Okay, so any more questions? There you are.
Hello, and thank you so much for your good presentation. I wonder, did you have difficult modeling the leaves? Photogrammetry can be difficult to thin surface objects and bushes. Could you modeling the leaves separately using the photometric stereo method and adding them to tree give a better results? Thanks. Photometric stereo technique, which is based on the shadows and lighting technique for using the little objects and so on.
So are you trying to ask whether they can detail the leaves through the process?
Yes. For this research, I'm focusing on the leaves. But actually, if I collect some images of the blossoms, flowers, it can be made some simulation of the blossoms, I think. This time we just want to show these techniques for the generating for the plants. So I just use the tree
Basically, I want to ask this. Did you have any trouble modeling the leaves? Yeah.
Yes. This time I just choose a very simple tree. It didn't have any background. It's very simple things, but as I show in the park scenes, in this video, it also have a lot of simple tree, but because of the complex of these things, it's generated not very good and have a lot of room of improvement, just like this noise. So I think it still have a lot of limitation of the generating. Thank you so much.
Okay. Oh, there you go.
Can I ask about the scene is after you apply the model?
Applied model?
So actually, I just try to follow up his comment, which those model of instrument nerve is to solve the confliction of different views. But in your case, usually it should encounter this kind of confliction based on the multi-view. That's why they try to distillation for the 3D representations. But for your case, it's like, do you have encountered an issue of multi-view conflictions?
I think what he means is that the different views in VR, is there going to have some conflicts? Do you face this kind of things?
I'm not very understand this question.
No, because usually we understand when we play with this generating is usually 2D, so it's one view, right? So when a leaf, you're going to change angle, you notice there's something which conflicts, just mixed text and looks like a leaf with a mixed like a tree. So is there? Am I asking this exactly? Yep. So do you have this kind of problem? Because right now during the whole presentation, you are just showing at one angle. Yes, you do turn, but then it looks from afar. It looks like a tree, but if we go close, do you have like conflicts that it doesn't look like a tree?
Oh, I think in the final video, it can be. Yes, I think this also has some limitations because at this angle and this at this distance is not very good. But we be more closer. These leaves are not very textural. I think it can be. It can be changed. I also have a lot of improvement of the leaves textural.
Sure, of course, there's always need to have improvements. No.
Yes.
Yeah, so yeah, we do have times issues and everything, but this lady is the Young CAADRIA Awards. Remember her? Okay, so she will be around. Stay tuned, and if you have any questions, find her, look for her. Okay. Let's go for the next paper.